Hello everyone, welcome to IMS Academy. I am Atul Negi, the lead mentor at IMS Academy. I hope you have enjoyed the last session of Theory of Machine where we have talked about the simple mechanism, flywheel and a gear train. So now in this particular session, we'll be more focused on the vibration topic and as well as the balancing part. So we will solve some of good quality questions from the vibration and as well as the balancing topic, right? So some of you who have not attended the live session, please go and watch the recordings after the completion of this session. We have discussed some very beautiful questions from the simple mechanism topic as well as from the flywheel and a gear train. Okay, so we'll start the session with the vibration topic. But before going into the details of vibration topic, let me tell you some of the important topics of the vibration chapter so that you will have a clarity. Okay, these are the topics we need to prepare. If I talk about the weightage of vibration in entire theory of machine, it is like very high weightage it is there. You cannot ignore the vibration topic. Now in vibration, which of the topics, which of the concepts are important, that I will list it here. Okay, I will write down all those topic names here itself, so that you will have a complete clarity about vibration chapter only. Okay, very good evening, Matan. So if I talk about the vibration topic, right? See, in vibration topic, first of all, you have this natural frequency questions. You have natural frequency questions. Okay, then you have simply the damped vibration cases. Damped vibration case. Okay, where you have a very important factor, that is damping factor, which is nothing but the ratio of damping coefficient divided by critical damping coefficient, which can also be written as like this, C by 2m omega n, which can also be written as C by 2 into root k into m, like this. Okay, so very important factor in the damped vibration case. Apart from that, we have one more thing, which is logarithmic decrement. Logarithmic decrement. It is the natural log of the ratio of two successive amplitudes. Okay, in underdamped vibration. So that logarithmic decrement is one of the most important topic last year, and many previous year questions, if you see, those are from the logarithmic decrement. Now, according to the definition, we will write the natural log ln xn divided by xn plus 1, ratio of consecutive amplitudes. If I take the natural log of ratio of two successive amplitudes, you will be getting the natural logarithmic decrement. So that is what one of the formula from the definition. But there is one more derived formula in which damping factor value is required only. This is there. Clear? Now there is one more formula. Okay, there are 2 and 3 formulas. Basically, total 3 formulas are there from the logarithmic decrement. So we need to know all those 3 formulas. So basically, as I mentioned, the ratio of successive amplitude is what? Constant. So x0 by x1, x1 by x2, x2 by x3, and so on. It will be equals to e to the power logarithmic decrement, right? Now if I multiply all those ratios, what I will be getting? If I multiply all these ratios, you will be getting here x0 by xn equals to e to the power n into logarithmic decrement. Now again, if I take the natural log on both the sides, I will be getting ln x0 by xn, equals to n into del, and from here one more formula you will be getting for the logarithmic decrement, that is 1 by n number of cycles ln x0 by xn. This is another formula. Total 3 formulas we are having for the natural logarithmic decrement, right? So logarithmic decrement, we have total 3 formulas. This is one of the formulas. from the definition. This is another one, and this is the third one. So total 3 formulas are there. All 3 you have a complete clarity about all 3 formulas, right? So natural frequency is there, damped vibration is there, logarithmic decrement it is there. Now next that you are having is the forced vibration cases. Next topic that you have in the vibration topic is forced vibration. In forced vibration, the very important topic is amplitude of steady state vibration. Amplitude of steady state vibration. Right, amplitude of steady state vibration it is there. Now in amplitude of steady state vibration, we need to know the formula, like F naught by K, which is our static deflection. In denominator you will be having under root 1 minus R square whole square plus 2 into damping factor into R whole square. This is there. So these are some of the important details that I want to mention it here, so that you will have a complete clarity about the vibration chapter. Okay. So amplitude of steady state vibration is there. Next you have one more thing, that is magnification factor. You have magnification factor, which is nothing but the ratio of amplitude of steady state vibration divided by the static deflection. So from this formula only you will get the answer. Amplitude of steady state vibration divided by the static deflection, which is F naught by K, which will be finally equals to under root 1 minus R square whole square plus 2 into damping factor into R whole square, like this. Clear? So very basic thing. Now one more thing that we have is transmissibility ratio. Transmissibility ratio. Okay, that will be equals to force transmitted by the force applied F naught, and that ratio is again a very important, very important. If you see, there are 2-3 numericals already has been asked from this one, transmissibility ratio. So 1 plus 2 into damping factor into R whole square divided by under root 1 minus R square whole square 2 into damping factor into R whole square. Like this it is there. So these are the topics that you need to understand. Okay, in vibration, at least this much so I need to cover, because sometimes a direct formula based question comes, and if you know all those formulas, you can easily solve vibration problem. You can easily solve the vibration problem. There will not be any problem at all, right? So I hope you have understood the whole vibration topic, that whatever topics we have to cover in the vibration topic. Okay, in vibration chapter itself. So amplitude of steady state vibration, magnification factor, transmissibility ratio, these are the things we need to cover. Now let us start with the problem here first of all. Okay, from the vibration topic itself, right? So everyone please read the question that they have mentioned in this one. Is there is a machine having a weight 68 Newton mounted on a set of springs, right? And then whose equivalent spring stiffness K value also they have given, damping factor also given, and one more thing they have mentioned, arranged vertically in a rigid foundation. Okay, a piston within the machine weighing 2 Newton. Okay, there is a piston basically having a weight of 2 Newton, has a vertical reciprocating motion. Reciprocating motion is there. Okay, fine. With a stroke of 8 centimeter and crankshaft with a speed of 3000 RPM. Okay, fine. Assuming the motion to be simple harmonic, determine the force transmitted to the foundation. That is what they are asking. Force transmitted to the foundation. Immediately you should think about the transmissibility ratio. If you are able to calculate the transmissibility ratio, you can easily get the answer of force transmitted to the foundation. Just now we have written the formula. So from this ratio you will get transmissibility ratio, then F naught multiplied by that ratio you will get force transmitted very easily. So first of all, whenever they are asking force transmitted to the foundation, you have to think about transmissibility ratio. Now to calculate the transmissibility ratio, what are the parameters are required, how you will calculate, if it is given directly in the question or not, or we have to use some other relations to get those parameters. So that you have to decide. Okay. So question is there in front of you. You have the time, 5 minutes. Please solve and tell me your answer in the chat box, everyone. Okay. Everyone, please start solving and tell me your answers. The force because of the reciprocating motion, how you will write it? The unbalanced force, mr omega square, right? The static unbalanced force that will be there because of the reciprocating motion is actually mr omega square. So F naught value will be mr omega square. Okay. Apart from that, all the data is given in the question directly. So first of all, in the question, always you have to write the given data, so that you no need to again look back to the question again and again. Once you have read the question, write down the given data, and then there is no need to see the question again and again. You have written all the data. From that only you have to think about, okay, which relation I need to apply. So that is what very important here, everyone. Writing the given data is very, very important. Just after reading the question, write it down, all the given data. Okay, last 3 minutes you are having. Write down the given data. Transmissibility ratio formula we need to apply. From the transmissibility ratio formula, you will get transmissibility ratio answer. That is nothing but the ratio of force transmitted divided by the F naught value. Right? I hope you are able to understand how to use that transmissibility ratio, and from where I got a hint, okay, I need to apply that formula, because directly they was no force transmitted to the foundation. So directly I will be using transmissibility ratio. See, purpose of transmissibility ratio is to what? We'll get a idea how much effective vibration isolation system we are having. It is used as the evaluating the effectiveness of this parameter. Transmissibility ratio is used as the evaluating the effectiveness of the vibration isolation system. We want to evaluate the effectiveness, so for that we will calculate the transmissibility ratio, right? Okay, last 1 minute 30 seconds, everyone. So sometimes from the question language you might think, okay, this is some kind of difficult question. No, read it carefully, see from which topic they have asked this question, write down the data, and then think about the relations that you can use here. You have to write the data, then only you will get a hint in your mind. Okay, things will come to your mind. Okay, this kind of relation I can use because this data is provided. All the data you will write it at one place. Now that will give you the sometimes the hint also. Otherwise, you are reading everything and then everything is what scattered. All the information is what is scattered here. But when you are writing all the data in this given section, you will automatically get an idea. Okay, yeah, these are the data given. I can use something, this formula or this relation I can use. So this is what very important. Everyone should understand. Last 20 seconds you have now. Anyone got the answer? See, one by one all the data we will be writing. Machine weight 68 Newton. So mass will be 68 divided by 9.81. So we will get the mass of the machine. Fine. And equivalent stiffness of the springs they have given 1070 Newton per centimeter. Here itself you should convert it into SI unit. What is the SI unit? Newton per meter. So Newton per centimeter, you have to convert centimeter into meters. So 10 to the power 2 will go to the numerator. Right, this is there. Then damping factor they have given 0.2. Arrange vertically on a rigid foundation. Fine. The piston within the machine having a weight of 2 Newton. Now, weight of the piston, which is having a reciprocating motion, it is having a mass of 2 Newton. So, to calculate mass of piston, we will again divide by 9.81. Right, this is there. Apart from that, stroke 8 centimeter. Stroke equals to 8 centimeter. Now, I hope you know already that stroke equals to twice of crank radius. Twice of crank radius is equals to stroke. So, crank radius will be about 4 centimeter. Right. And RPM they have given as 3000 RPM. Now, that from 3000 RPM we will get the omega excitation frequency, that is 2 pi n by 60. By 60, you will get the excitation frequency. Then omega n is also required, K equivalent and mass is there. So, omega n also we can calculate. Natural frequency of the system, K equivalent by the mass of the machine basically. Right? One by one all the data we will write here. So, first of all 68 divided by 9.81, that is 6.93. And weight of the piston they have given 2 Newton. So, 2 divided by 9.81, that is 0.203. 0.2038 kg. It is there. Now, omega we will calculate 2 into pi into 3000 divided by 60, it is there. So, 314.159 radian per second. And in this case, K equivalent value 1070 into 10 to the power 2 divided by, you are having a mass how much? 6.93. So, you will get omega n also from here. So, 1070 into 100 we have divided by 6.93. 6.93 you are having. Under root of this value will be 124.258. 124.258 it is there. 124.258 radian per second. Now, these all the data we have calculated here first of all. Now, transmissibility ratio, the formula we need to know, that already we have written here also. This is what transmissibility ratio formula. Okay. Now, TR equals to under root 1 plus 2 zeta into R whole square. One minus R square whole square 2 into zeta into R whole square. Right. Now, first of all, R value, please understand what is R value? Omega by omega n, ratio of excitation frequency divided by the natural frequency. Okay. Here itself we will calculate here. Omega by omega n. So, that is 314.159 divided by 124.258. That is coming around 2.528. 2.528. That is what the value. So directly we have calculated all the values which is required in the transmissibility ratio formula. Right. Now one by one all the values we will put here. 1 plus 2 into damping factor, already it is given 0.2 into 2.528 whole square, right? Then we have 1 minus r square, 2.528 square whole square, then again 2 into damping factor 0.2 into 2.528 whole square, right, like this. Right, now just do the basic calculation, you will get the transmissibility ratio. So 2 into 0.2 into 2.528, it is there. Okay, square of this value plus 1, under root of this value will be 1.422. So in numerator 1.422 it is coming. Now again please understand, don't try to do all those calculations directly in the virtual calculator. You should do it in a part. First numerator you have calculated, then denominator, then you have divided. Don't try to write the entire formula in the virtual calculator. There will be a chances of mistake then. Okay, there is no problem in doing the part wise calculation. First numerator part, then denominator part. Within numerator also first this part, then finally numerator you will be getting. So please take care of the calculation part. It is very, very important. Sometimes we have like everything we have done correctly, but in the last, just because some data, because we are in hurry and we have put wrong data, or we have not applied the correct brackets in the virtual calculator, and then we'll get finally wrong answers also. So bracket BODMAS rule is very important, specifically when you are writing entire equation in the virtual calculator only. So please remember this point. Okay, so now next we have 2.528 square value minus 1, then again square, plus you have again this value 2 into 0.2 into, then you have 2.528 square. So 5.48 it is coming, approximately 5.48. 5.484. So everyone please cross check the values also. Parallelly you should do the cross check. Okay, please try to cross check the values. So 1.422 it is there, divided by 5.484. So approximately it is coming 0.259. 0.259. Approximately this is what the value we are getting. Okay. Now what we need to do next, as we already discussed, transmissibility ratio is actually the ratio of force transmitted to the foundation divided by the F0 value. F0 value, because they have given a reciprocation motion, for that the static unbalanced force will be mr omega square. Mr omega square will be the static unbalanced force. Okay, so Ft will be equals to this transmissibility ratio 0.259 into mr omega square. Obviously mass of the piston, that reciprocating part is creating the unbalance, na? That reciprocating part is creating the unbalance, mr omega square. So mass will be for the piston. R is what the crank radius there. Mass of the piston we have calculated already, 0.2038. Into crank radius was 4 centimeter, that is 0.04. And omega also we have calculated, that is 314.159. Okay, like this. So you will get the answer of force transmitted to the foundation. Very easily you will get the answer. So 0.259 into 0.2038 multiplied by 0.04, then 314.159 square. So 208.38 approximately you will be getting the answer. 208.38 0.38 Newton. So please everyone do the cross check calculation part. Please everyone do it. You should parallelly do the calculation and cross check the answers. 208.38 or 209 approximately you will be getting. So every numerical which is there in the 2 marks, you will find it in NET. It will be in the NET, right? So there will be no negative marking there. So but please take care that whenever you are doing calculation, don't take any approximation in the initial steps. Otherwise the final answer will have a huge variation compared to the actual expected answer. And in some times what will happen, your answer will not come in that range which the IIT, the GATE Institute, whichever has prepared that exam prepare. So whatever the solution they will provide, in that range your answer will not come. And that many times I've seen many students were saying ki sir, I've done everything correctly but my answer is not coming in the range, and that is there because of the point you have initially taken some approximation in the calculation, and with that approximations you have done later on 2, 3 and 4 more further calculations, and then finally answer will be having a huge variation. So please remember this point, you don't have to take any approximations. You should not take any approximations initially. So make a thumb rule that up to 3 decimal places or up to 4 decimal places you should take the calculation. At least up to 3 or 4 you should take, not up to 2. Up to 3 or 4 decimal places you should do the calculations, and then finally we will say okay, final answer we can basically approximation we can write. But if in the starting itself if I'm doing, so see in this question how many calculations we have done. If I have taken approximation in the initial step itself, after that multiple times I have used that value. So how many times I have used that value, based on that variation will be there. Okay, so please make sure that and make a thumb rule that you will never use approximations in the initial steps. Right? You will never use approximations. Take up to 3 decimal or 4 decimal place calculations and then use that one only throughout the whole solution part. So finally force transmitted to the foundation answer is 208.38. That is what the solution of this particular question. Understood everyone? So there are so many problems like that. Okay, we'll be solving multiple questions from the vibration, because see why I'm focusing more on vibration. Definitely from vibration 1 or 2 numerical will definitely come. Okay, not one, sometimes more than 2 numerical will come, 2 questions, but 1 question 100% it is sure that question will come from the vibration. That is fixed. Every year you can just look at the previous year question booklet. You will find every year there is 1 question from vibration. So why not prepare that vibration in that way, right? Now let's move on to the next problem everyone. Okay, but before moving to the next problem, as I already told you, test series plays a very important role in the GATE preparation part. So you have to make sure that you are practicing in the GATE test series, whatever the test series format is there. In actual, see, the test series format interface, that is what required. You need to practice in that environment multiple times. So there are multiple mock tests are available in the test series plus product. Apart from that, chapter test, subject test, multi-subject test, basic, advanced, all of those tests you will be getting. And the best way to evaluate yourself is to give the test. You need to evaluate yourself. You need to see how much you are able to perform based on the preparation you have done. If there is a gap, you will find out that gap. Whatever the weakness you are having in your preparation, you will fill those gaps. You will try to make sure that those weaknesses will become strength for you. But for that, you need to identify those things. How you will be able to identify? You have to give the test. Then only the proper identification will be there of your strength and weakness. Right? So apart from that, previous year booklets you will be getting for technical subjects and for aptitude and mathematics separately, 2 technical booklets. And in this last moment, sometimes what happens, there are a lot of numericals we are solving and we are getting a lot of doubts and lot of problems we are facing in solving numericals. So for that, we have a doubt solving portal where you can post all your doubts. Any numerical related doubts you can post in the doubt solving portal. You will get the solution as soon as possible. And finally, apart from that, you will be getting the mock interview help also and the revision sessions. So 20% off is right now available. You can directly click on the link which is provided in the video description, and as well as in the chat box there is a link provided. You can use that link to get the test series plus product, right? So next we will start the next problem. And one more thing, many of you are still in third year or second year, you can join IMS GATE Academy live online program where you will be getting more than 800 hours of session. Apart from that, exercise book you will be getting where questions are arranged in level 1, level 2, level 3, like that. So enough practice material you will be getting. You don't need to have any reference book after that. If you are solving exercise book, attending the live lectures, that is more than sufficient. You never need to look for any reference book. Doubt solving portal will be there, and most important thing is the one-to-one mentorship sessions. These mentorship sessions are designed in such a way that whenever you will feel any problem in your challenge you're facing in your preparation, faculty will be there. You can directly connect with the faculty and you can discuss whatever the problems you are facing in your GATE preparation. Okay, and always you will have a hand-holding, complete hand-holding you will be there in your GATE preparation journey. So you will never feel alone, okay? Whenever you will stuck, someone will be there to help you out, okay? So if you are interested in the live online program, already the batches are started. You can directly call on these numbers to book a free counseling sessions, right? Now, moving on to the numerical, next, again a vibration numerical will be more focused on vibration in this session. In this session will be more focused on the vibration topic, right? Because of the requirement actually. In theory of machine, mostly questions are coming from vibration topic. So we have to have a complete understanding, complete clarity of all the concepts in vibration. PYQs already you have done. So these are not the PYQs, right? These are the different questions that you need to solve before writing the GATE examination. At least you will have a different flavor of questions, different variety of questions you will be having. So PYQs already you have done, but now you have to solve some different set of questions which will give you confidence as well. Okay, now please look at the question here. Vibrating system of a coil spring, stiffness 50 Newton per mm, supports a vibrating mass of 250 kg at the free end. Okay. In addition, the motion of a mass is controlled by the dashpot whose resistance is proportional to velocity. From measurement, it is found that amplitude, this is very important information, at the beginning of the fourth cycle is 0.8 times the amplitude of the third cycle. Determine the ratio. What is the, they are asking ratio of frequency of damped and undamped vibration. You need to understand first of all what actually they are asking. How much for only online mock test series, sir? Pawan, you can directly click on the link. You will get all the details there itself. Okay. And if you are facing any doubt, there will be a number also. You can directly call on that numbers. Okay. You will get all the details regarding whatever the test series if you want without any book. So whatever the requirement is there, based on that you will get the details. You can directly call on the numbers as well. Right, Pawan? Okay, if any other doubt is there, please mention in the chat box itself. Now, please look at the question here. This is a very interesting question. Okay, this is like a very interesting problem. First of all, you need to understand what they are asking. Ratio of frequency of damped and undamped vibration. It means they are asking damped frequency omega d divided by undamped frequency, that is omega n. This ratio they are asking. Damped frequency divided by the natural frequency. Undamped means what? The natural frequency. Now, is there any relation between omega d and omega n? Yes, absolutely. So you should remember the omega d relation. What is that omega d relation? Under root 1 minus damping factor square multiplied by omega n. So we should write it like this: omega n multiplied by 1 minus damping factor square. So basically omega d by omega n is nothing but 1 minus damping factor square, under root 1 minus damping factor square. Now, next thing what I will think about here, how to calculate the damping factor. Now, all my attention, all my focus will be on damping factor. If I know the value of damping factor, I will get the answer. Now, how to get damping factor? Just read the question again, write down the given data and try to think about the damping factor. If you are able to get the damping factor, you will get the answer very easily. Write down the given data. As I told you already, first of all, write down the given data. That will give you a hint also how to approach a problem. Just by reading the question will not going to help you. Are you getting my point? You have to write down the data as well. Okay. So your time starts now here. Okay. Everyone should try and tell me your answers. Start. Write down the given data first of all. Try everyone. I already given you the hint here how to solve this question. Because the main thing is the damping factor. Aditya, decrement ratio given. Yes, decrement ratio you can use, logarithmic decrement relation you can use it here to get the answer of damping factor. Correct, absolutely correct. Tell me what will be the answer, Aditya? Aditya, what will be the answer? You should solve it fast because already you know the approach, which relations we have to use. So all of the things are clear to you, then you should be able to solve the question as quick as possible. Last 2 minutes. Thank you so much, soil mechanics. Excellent questions. Yes, we are discussing the excellent questions only, right? PYQs already you have done. You gain the confidence from the PYQ, but at this point, we have to focus on different variety of questions. For that only the gate booster has been designed for you students, right? So you will be getting a very good questions, excellent questions you will be getting here, and if you practice this question, not only the confidence will increase, you might see similar kind of questions in your upcoming gate examination as well. So try to attend all the gate booster series sessions live. Okay, even if you have not watched live, at least attend the recorded lectures and make a note of all the questions. last 10 seconds now. Anyone has solved? Aditya, you were telling something, logarithmic decrement. Have you solved the question or not, Aditya? Okay, we'll see what answer you are getting, but we'll start the solution part here. First of all, the given data. Okay, first of all, the given data we will write. Okay, so given data, first of all, stiffness they have given 50 Newton per mm. So 10 to the power 3, it will go like this, Newton per meter. Because mm is 10 to the power minus 3, that minus 3 goes to the numerator, it will be 10 to the power 3. 0.99 you are getting. Okay, we'll see whether it is correct or not. Mass given 250 kg. Apart from that, they have given amplitude of at the beginning of fourth cycle is 0.8 times of amplitude of the third cycle. How to use this data? See, amplitude of fourth cycle is 0.8 times of the amplitude at the end of third cycle. This was the data given. Logarithmic decrement is equals to natural log of consecutive amplitudes, that is x3 by x4. It means delta will be equals to ln 1 by 0.8. 1 by 0.8 it will be there. Correct? 0.99 you are getting the answer? Yes. Okay. Just a minute. Logarithmic decrement we have calculated, and we already know this another formula that we have is 2 into pi into damping factor under root 1 minus damping factor. That's it. So just calculate this one values, everyone. 1 divided by 0.8, that is 0.2231. 2 into pi. Can you tell me the damping factor value? Aditya, what is the damping factor value? Is it 0.99 only? You can tell me the damping factor value. Is it coming 0.99? So what we will do, we will square on both the sides. 0.2231 square. Okay. It is there. And this 2 pi. So 2 into pi it is there. Divided by 0.2231. We'll do the squaring. Okay, fine. Like this. And this one will be square and this square root will get cancelled out. Okay. So 1 minus zeta square here is, it will be there, and zeta square will be there. Right? 0.99 it is coming, approximately 0.99. Damping factor value is coming 0.99 approximately. Is it like that? 0.0354. Okay. So if you just cross check the value, 0.0354. This is the value. The final answer is 0.99. So that is damping factor, and they were asking about omega d by omega n under root 1 minus 0.0354 square. So if I do that thing, 0.0354 square, 0.99. Yes, absolutely correct answer, Aditya. Your answer is correct. 0.99 is the correct answer. 0.99 is the correct answer for this particular problem. Absolutely great. Right. So the given data we need to understand what they are asking for that. What are the relations we are having to calculate that value? Is all the parameters are directly given in the question or not? That is the second thing we need to see. If it is not given, then what are the relations I can use to get that those parameters which are required to calculate the given unknown? Whatever the unknown they are asking for that, whatever parameters are required, first those parameters I will calculate. And how we will get the idea key how to calculate those parameters? We will see the given data, na. With the help of given data only, we'll be able to calculate those parameters, right? So determine the ratio of frequency of damped divided by undamped, omega d by omega n answer. They're asking that is 0.99, absolutely correct. Okay. So logarithmic decrement we have calculated, we have used the definition formula and modified formula also. Both the formulas we have used to get the damping factor answer. Now moving to the next problem. Next problem everyone. Now look at the next problem. Machine part of mass 2 kg vibrates in a viscous medium. Determine the damping coefficient when a harmonic exciting force of 20 Newton results in a resonant amplitude of 12 mm with a period of 0.2 seconds. Again, a very easy question, but you have to be careful regarding the data that they have given. So if you have not understood the data properly, if you have not interpreted the information correctly in the question, then chances of mistakes are very, very high. Chances of mistakes will be very high then. Read the data carefully, everyone. Read the question very carefully, everyone. As I told you always, first of all, you need to write down the given data and then think about what actually they're asking, what are the relations in which that unknown will be there, what are other parameters which are required, all those things you have to see. Okay. Last 2.5 minutes, everyone. Any answer, Aditya? What is your answer? Last 1 minute now you are having. how to approach this forced vibration question. Aditya, again see the question. Exciting force of 20 Newton results in a resonant amplitude of 12 mm. Correctly you observed, it is a forced vibration question. Absolutely correct. Other data also you need to focus. Now, see. First of all, the data, mass 2 kg. Okay. So this is given data. First of all, mass equals to 2 kg. Determine the damping coefficient. Damping coefficient they are asking. Okay. Excitation force F naught, which is 20 Newton. Results in resonant amplitude. What do you mean by this resonant amplitude? Amplitude at resonance condition, simply. Amplitude at resonance condition. Okay. Aditya, no need to worry. In forced vibration, there are a few things that we need to look at. Okay, I've mentioned here. In specifically forced vibration, three things: amplitude of steady state vibration, magnification factor, and transmissibility ratio. These three things you need to focus. That's it. In entire forced vibration case, these are the three things. Right. Now look at the question here now. So resonant amplitude. Now at resonance, what you know, it will be omega equals to omega n. Omega equals to omega n. Clear? At resonance, omega equals to omega n. Fine. They have given a period of 0.2 seconds. So omega n value, you can write it like this: 2 pi divided by time period. 2 pi divided by time period, you can write easily. Okay. So 2 into pi divided by 0.2. That will be 157.0796 radian per second. That is what omega n, 2 into pi 0.2, that is what time period they have given. Just a minute, it is 31.4. See, this is 31.4159. Correct? So this one is correct. You can just cross check also, everyone, and let me know. Yes, 31.4159, it is there. Omega n I have calculated. What they are actually asking, damping coefficient. Damping coefficient, see, you need to write it also. Whatever unknown they are asking, you should write the relations related with that unknown. Damping coefficient equals to, we can write it like damping factor multiplied by critical damping coefficient. Because from where it came, we already know that damping factor is damping coefficient divided by critical damping coefficient. Now damping factor is required, critical damping coefficient is required. Okay, damping factor is one of the things, but what is critical damping coefficient? 2m omega n, which can also be written as 2 into root over k into m. Mass is given, but k is not given. K is also unknown, damping factor is also unknown. To get the answer of damping coefficient, what is required? Damping factor as well as k, because mass is given. These two values are required. So in the side we have written, okay, these are the parameters are required. What I will do to get those parameters, that is what I need to think. Okay, fine. So resonance condition we have written omega n. From omega n under root k by m, k value I will get very easily, because omega n equals to under root k by m. Omega n value already we have calculated, so K answer will be getting. There is no problem. What about the damping factor? How to get the damping factor? That is what very important question. Resonance amplitude 12 mm. Is there any relation of amplitude? Yes, already we have written also. Amplitude formula is F naught by K. See, F naught by K under root 1 minus R square whole square 2 into damping factor into R whole square, like this. Now, as we have a resonance condition, at resonance condition, omega equals to omega n, that is R value equals to 1. Omega equals to omega n, R value equals to 1. So the formula of amplitude, how it is going to change? R value 1, so this one becomes 0. F naught divided by K divided by 2 into damping factor. Because R value is 1, na, this one becomes 0. So under root will get cancelled out because of the square. So amplitude already they have given. That is 12 mm, 12 into 10 to the power 3, because in terms of meters we have to write using the SI unit conditions. F naught they have given, yes, 20 Newton divided by K value. Okay, K we have not calculated, just we will calculate the K value here. 31.4159 square we have to do, multiplied by mass. So that mass is what? Mass is 2 kg multiplied by 2. So you will be getting the answer here, because you have to do the squaring. So omega n square will be there. Omega n square will be K by M. So omega n square multiplied by M will give you the K value. So that is coming around 1973.917 Newton per meter. Like this, 1973.9175. Okay, up to 4 decimal places, let's suppose. Fine. This is the value of K. We will substitute here. 197.9175 divided by 2 into damping factor. Now, from here you will get the answer of damping factor very easily. And damping factor also you have solved. K value also you have solved, you will get the answer of damping coefficient very easily. Now please do the calculation and tell me your answers. First of all, damping factor answer I want. Tell me the answer of damping factor, everyone. What is the answer of damping factor, everyone? Please do the calculation. Anyone got the answer of damping factor? So please cross check. The answer that I am getting here is 0.422. 0.422 is the answer of damping factor. So once you have solved the damping factor, okay, now K also we have solved. What we need to do? Directly we will write like this. Yes, correct. Aditya, 0.422 is absolutely correct. Now damping factor next, please calculate the damping factor value next. K into M. K value was 1973. So 1973.9175 into 2 under root of this value multiplied by 0.422 into 2. 53. Yes, correct, absolutely. 53, approximate answer is 53.03 Newton second per meter, like this. Correct, absolutely correct, Aditya. 53.05, yes, it will come in range, no issue, correct. That is also correct. So now I hope, Aditya, you have understood like how to solve a forced vibration question. I've told you in forced vibration there are hardly 3 formulas, okay. Amplitude of steady state vibration, because in the forced vibration there will be a amplitude of steady state vibration. That formula you need to remember. Actually this F naught by K, sometimes they will directly give the static deflection. So you should not be worried about ki sir how to calculate F naught by K, because sometimes in the question itself they will mention static deflection is this much without giving F naught and K separately. So this F naught by K is static deflection. And you should also remember magnification factor is the ratio of amplitude of steady state vibration divided by static deflection. So without even mentioning ki magnification factor they are giving, they will simply tell in the question itself the ratio of amplitude of steady state vibration and static deflection is this much. So we need to know ki what actually the information they are giving, how to use that information. Okay, you have to be clear with all the parameters. So magnification factor ratio only, amplitude of steady state vibration divided by static deflection, that's it. This one we should remember. Okay, and then transmissibility ratio. These are the 3 important relations that we are having in the forced vibration case. Okay, now moving on to the next problem. Next, everyone, next this problem, try. Again, first of all, the important thing is writing the given data. Write down the given data and then solve. Right, solve this one. Okay, so for this one also I will give you the same 5 minutes only. 5 minutes I am giving you so that you can apply whatever the concepts you have learned till now, and at least you will try, you will get the answer also. So that much time, but obviously in the gate examination we have to be very quick. Okay, immediately after reading the question you should decide whether this question I will attempt or not. So they have mentioned a 350 Newton electronic instrument, right? 350 Newton, that is what the weight they have mentioned, is attached to a ship deck which vibrates at an amplitude of 1.6 mm at 50 Hertz. So this is amplitude of vibration. This is what the Fn, this is what the frequency of vibration, not Fn, it is a frequency of vibration, F. The instrument is to be isolated from the deck with 4 flexible mounts. Determine the required combined spring constant of the mounts such that the amplitude of vibration of the instrument is no more than 0.13 mm. So you have to see two different amplitudes they have given. What will be the constant in both cases? Which constant you are talking about, Aditya? Which constant? Spring constant. Stiffness only we need to calculate. Spring stiffness we have to calculate in this case. Two amplitudes are given, so two cases will form. See, okay. Yes, two amplitudes are given. That 1.6 mm at 50 Hz, that is what static deflection. And what they are saying ki finally the amplitude should not be more than 1.3. That is what amplitude of steady state vibration that we will have. See, first of all, mass 350 divided by 9.81. Okay, 35.677 kg it is there. Amplitude of 1.6 mm at 50 Hz. So they have given the static deflection. You can write it like this, static 1.6 mm, right? And instrument is to be isolated from the deck with 4 flexible mounts. Okay, determine the required combined spring constant. Amplitude of the vibration of the instrument is not more than 0.13. So that is amplitude of vibration, that is what required is, it should not be 0.13. In question, nowhere they have talked about the damping. So damping factor has to be 0. Damping they have not mentioned in the question, because in vibration isolation systems, please understand, springs and damper both are used, but they have not mentioned anything about a damper. Nothing has been mentioned about the damping. So damping factor we have to take it 0. So now the relation that you will be having, okay, either X you want to write or A you want to write, it's up to you. Okay. the formula will be under root 1 minus r square whole square okay. X value 0.13, this is 1.6. Now this one will become 0. So under root 1 minus r square whole square it is there. Are you getting the point? So plus minus sign will be there because after the removing of the square root, plus minus sign will come. And we have to see whether plus is correct or minus is correct. Okay, it depends. Aditya, is this point clear first of all? 0.13 divided by 1.6 plus minus 1 by 1 minus r square. So let us write 1 minus r square here. So 1.6 divided by 0.13, it will come around 12.30. 3076 like this. Now if I take positive here, r value will be under root of minus. That will be wrong. I need to use minus sign here actually. I cannot use positive. If I am taking positive, r value will come in imaginary. That is not possible, right? R is the ratio of frequency. How the ratio of two frequency can be imaginary number? Not possible. So we have to use negative sign here. So after using the negative sign, you will get the value of r very easily. Okay, r value will be getting. So r value, how we will solve? See, 1 minus r square it is there, right? Okay, r square minus 1 plus r square. So minus 1 goes to that side, it becomes plus. So 12.3076 plus 1 and you will take the square root of it, it will come around 3.647. So it will come around 3.6479. Clear? This is their r value. Yes, 3.6 something it will be there. So 3.6479 up to 4 decimal places I have taken. So that is what r value. Correct. Now what is required actually? The combined spring stiffness. Combined spring stiffness, how you will calculate? First of all, r value you should know. What is r? Omega by omega n. Omega n we have to calculate first of all. Omega by r. Okay. What is omega? See, 50 hertz it is there. Okay, it will be 50 hertz. Or you can directly write like this also. F by Fn. Ratio of omega by omega n equals to F by Fn also, na? In that way also you can write. Now see how we will do then. Then you will be getting Fn answer as F divided by R. Fn 50 divided by 3.6479. So Fn you will be getting. So let me just write down the value. 50 divided by 3.6479. That will come around 13.7065 hertz. Now once you have calculated this thing, omega n equals to 2 pi Fn, and then omega n you will equate. So 2 into pi into 13.7065. Yes, so that is 86.120 equals to under root K equivalent by mass. So from here K equivalent answer you will be getting very easily. Okay, K equivalent answer you will be getting very easily. Now tell me your answer of K equivalent. K equivalent answer. Do the squaring and then calculate. Mass we have written, na? Yes. Mass initially only we have calculated 35.677. 35.677 it is there. So squaring of 36.1204 multiplied by 35.667. Okay. What is the answer? In kilonewton per meter, you should tell me the answer. In kilonewton. So the answer that is coming here is 264. Equivalent value of the stiffness. Yes, yes. So if you divide by 1000, now you will be getting 264 kilonewton something. 264.6 approximately kilonewton per meter. That is the equivalent stiffness. Absolutely correct, Aditya. Yes. Done, everyone, this question? Right. So see, we have solved different variety of vibration problems, from magnification factor, from transmissibility ratio, okay, from logarithmic decrement, from forced vibration. All those important numericals we have already solved here. Now one more problem that is very important with regards to natural frequency calculation part, that we have to see next. Okay. Now see the next problem. Determine the natural frequency of the system. This is again a very, very important question. Usually if this pulley kind of system it is given, always try to use energy method. Always try to use energy method whenever a pulley system they have given. What is energy method? In energy method we have to write down all the energies of the system, total energy of the system, and then differentiate with respect to time and equate with 0. You will get the equation of motion. From that equation of motion you will get the natural frequency. So first what you need to do, write down the total energy of the system. Then you will differentiate the total energy of the system with respect to time. Obviously total energy of the system will be constant because of no damping is there. So total energy of the system is constant. Differentiating with respect to time will give you 0. So from here you will be getting the equation of motion. And writing that equation of motion in standard form, you will get the answer also. Equation of motion you will be getting. And writing it in standard form will give you the natural frequency as well. So first of all, tell me how many energies are involved in this case. Tell me the type of energies. Please mention in the chat box the total energy of the system. Just write down ki, okay, this energy is there for this part, this energy is there for this part. No need to write down the formula. No need to write down any formula. Please just write what are the energies will be involved in the system. What are the energies involved in this particular system? Tell me. So let us assume that there is what the deformation or disturbance has been provided. Let us assume there is a disturbance provided, theta disturbance provided. Once you have provided disturbance, then you will see the changes in the system. Accordingly, you should write the energies. Tell me the energy, just write down the energy name. Spring, acceleration, rotational. Okay, but I am asking the energy now. So you are telling simply the motion. Energy. In a spring, what kind of energy it will have? Deformation will happen. Potential energy in the spring. Block will be moving. So kinetic energy of the block. Pulley will be rotating. Rotational kinetic energy of the pulley. Like that, total 3 energies we have to write. So what happens? Disturbance you have provided theta, right? How much distance it will move in the downward? That will be r theta. Obviously, let's suppose theta disturbance you have provided. So this much distance will be nothing but r theta only. So that r theta distance only the block is going to move, right? The block is going to move that r theta distance only. Correct. There will be a deformation happens in the spring also. That deformation, because of that deformation, potential energy is stored in the spring. So all those energies we will write, we will differentiate with respect to time, we'll get equation of motion, and then finally natural frequency as well. Okay, do it fast everyone. Just try to solve this question. Everyone should try. And if you face any difficulty in any of the step, please let me know. We'll discuss that solution. Obviously, we'll discuss it in detail, but still, at least first of all, you should try on your own. Everyone should try this numerical on your own first of all. Specifically in a given, whenever pulleys are given in a system, try to use energy method. Okay, chances of mistake will be less. Otherwise, so many times we have used Newton's second law or D'Alembert principle for calculation of the natural frequency. Using D'Alembert principle only, we are writing equation of motion. From that equation of motion, we'll get the answer. No? That is also there, but specifically in pulley system cases, energy method we have to use so that chances of mistakes we can avoid actually. Okay, I hope everyone has drawn the diagram. Here I will write. Total energy of the system, first of all, kinetic energy of the mass, kinetic energy of the mass m, plus kinetic energy of the pulley having mass capital M, plus potential energy of the spring, potential energy of the spring, kinetic energy of the mass M, okay, kinetic energy of the pulley, the rotational kinetic energy, and the potential energy of the spring. First of all, this one, okay, half mv square. That v square is nothing but x dot square. Velocity can be represented as x dot. X dot is what? Dx by dt. So x dot I can use instead of v. Rotational kinetic energy is half I omega square. I is mass moment of inertia into omega square. Omega means d theta by dt. So d omega equals to d theta by dt. So d theta by dt can be written as theta dot. Instead of omega, I am writing theta dot here. And then finally, potential energy of the spring, half kx square. Right? These are the three different types of energies we have written. Okay. Now, so this is total energy. What we need to do next for writing the equation of motion, we have to differentiate. We have to differentiate this thing. D by dt of total energy equals to 0. Now, if you differentiate this part, So half m x dot square it is there. So 2 x dot, then again x double dot will be there. So half will get cancelled out. X dot into x double dot, it will be there, plus mass moment of inertia. Now it is a pulley, right? So pulley means like it will be a disc. So half mr square will be there. But I am writing mass moment of inertia according to the given. It can be a ring also. Okay, it can be a ring also. Accordingly, the mass moment of inertia formula will change based on the given shape of the pulley. Okay. So I'm not writing the formula here, but if it is a disc, mr square by 2, that formula everyone knows. Same here, it will be there, mass moment of inertia theta dot plus theta dot multiplied by theta double dot plus this half kx square. So 2x will be there, so 2 will get cancelled out. 2 into x dot equals to 0. What is x dot? R theta dot. R theta dot it is there. Okay, now here also very important point, x, I will write the whole equation in terms of x or theta, it's my choice. I will not use the two different variables here. I can write the whole equation either in terms of x or in terms of theta. So it's our choice. I will write in terms of theta. So what I will write, m into x dot will be nothing but r theta dot. X double dot will be nothing but r into theta double dot. Mass moment of inertia theta dot multiplied by theta double dot. Now here it will be k into r theta multiplied by r into theta dot equals to 0. Now from whole equation theta dot and theta dot will get cancelled out. It will get removed from the equation finally. Theta dot will get removed from the whole equation. Now finally, how you will write equation of motion here? Please see, look at here, mr square theta double dot plus mass moment of inertia into theta double dot plus kr square theta equals to 0. So this is what we have as equation of motion. This is we are having as a equation of motion. Further we will simplify this one in the standard format. Further we will simplify this equation so that we'll have that equation in our standard format. Okay. Till this point, any confusion anywhere? Aditya, please tell me. If you have any confusion, any doubt in any of the steps, please let me know. We'll discuss it again. There is no issue. Is that clear completely? Done? Is that clear? Done. Okay. Now further we will write in standard format. What I will do, I will take theta dot common. So mr square plus mass moment of inertia into theta double dot plus kr square into theta equals to 0. Now theta double dot plus kr square divided by mr square plus mass moment of inertia into theta equals to 0. Now you have to compare this equation with the standard format. What is the standard format? Theta double dot plus omega n whole square like this. Correct? This is what the standard format. From this standard format you have to compare it. So this is what omega n square value. So I will write omega n value will be under root of kr square divided by mr square plus mass moment of inertia. So this is what the answer will be having for this question. Right, Aditya? I hope it is clear. So, okay, you have written the mass moment of inertia formula also for the disk mr square by 2. So, the resulting answer will be there accordingly. Right? Because mass moment of inertia formula for disk will be mr square by 2, but capital M. R square will get cancelled out from the whole equation. So, K divided by small m plus capital M by 2. That's it. That will be our omega n answer. That will be our omega n answer. Is that clear? Yes, absolutely. Disk formula, na? Correct. That's why you are getting that form answer. K divided by M, small m plus capital M by 2. Correct, absolutely. So just keep in mind, whenever a pulley kind of question comes, use energy method, you will easily get the answer without any difficulty. So energy method best suited in the case of pulley systems, right? Now, so we have seen lot of questions from the vibration. Now moving on to the balancing part. Again, second important topic here for the today's session. This kind of question still not they've asked. So this variety of question is also very important. Otherwise, balancing is like very easy. Balancing means what? Just taking the equilibrium, force equilibrium, moment equilibrium, two equations. Summation of force is 0, summation of moment 0. That's it in balancing part. Okay, so this one is like a different question that we have. So try at least this one first of all. Question from the reciprocating balancing case. Okay, reciprocating mass, balancing of reciprocating mass. I will give you the hint. Hammer blow formula you have to use. Hammer blow formula you have to use in this case. Option A you are saying 5. Yes, absolutely correct, Aditya. Superb. 5 radian per second is correct answer. Very good. Okay, we'll wait for others. Already I've told you hammer blow. The hint already I've given you. Hammer blow is the maximum value of the force. There is a lag. Yes, Aditya, I think because of some issue there is a lag here, but no issue. I'm getting your all the comments. I'm responding to all of the comments that you are mentioning in the chat box. So there is not issue. Yes, there is a lag, might be some technical issues there, but don't worry about that. Okay, so hammer blow, what I'm saying is the maximum unbalanced force perpendicular to the line of stroke. That is what hammer blow. Okay, maximum unbalanced force perpendicular to the line of stroke. Perpendicular to the line of stroke. Is it correct? Now, that will be written as balancing mass, position of the balancing mass into omega square. Now, please understand, in the question they have mentioned, if pressure on the rail is in the downward direction is 200 Newton, then the permissible value of angular speed. So, we will take that for the safe condition. For the safe condition, we will take this 200 Newton as hammer blow value. We will calculate the omega value from there. Okay. So, for safe condition, we will take the 200 value as the hammer blow. Balancing mass required is 80 kg. At what location? 100 mm, 0.1 into omega square. So from here, omega value you will be getting, right? So omega value that you will be getting here is 5 radian per second. Correct, Aditya? Is that clear? 5 radian per second will be the answer here. Done? Shall we move to the next problem of the balancing? Done. Next, this one. So this one a little bit lengthy problem, but still you will be able to solve it. Try everyone this question. Again from the balancing of rotating masses, so like very easy. Balancing of rotating masses is very easy, so that's why I'm not taking that part here. So this question is again from the balancing of reciprocating mass. Balancing of reciprocating mass it is there. %50 of the reciprocating mass in a single cylinder engine is what we need to balance. balancing mass first of all, then the net unbalanced force. Okay, you didn't revise. Okay, no issue. We'll discuss that part in detail. No issue. You will get to know all the important formulas and the relations. Don't worry about it. We'll discuss it. Last 1 minute. Okay. I hope you remember at least this point कि balancing of rotating masses is possible. Complete balancing of rotating masses is possible, but for reciprocating masses, complete balancing is not possible. This basic fundamental detail everyone should know. Balancing of reciprocating masses is not completely possible. So that's why we will prefer partial balancing. We will prefer the partial balancing. So that's what the topic also you will study, the partial balancing of reciprocating masses. Right? Now, please see. So first of all, this relation is very important. You need to understand MB RB, balancing mass and its position, equals to C into C is the percentage of partial balancing you are doing, mass of reciprocating mass multiplied by the location of the reciprocating mass, plus mass, which mass? Rotating mass multiplied by the location of the rotating mass. This is what a basic fundamental equation you should remember. So first part you will get the answer directly from here. Balancing mass they are asking. MB. RB required at radius of 320 mm. So 0.32. So balancing mass required at radius of 320 mm. So 0.32 I have written. How much partial balancing required? 50%. So 0.5. Reciprocating mass, how much they have given? It is 40 kg. Multiplied by the crank radius. Now crank radius, how I will get it? They have mentioned the stroke 350 mm. I hope you remember stroke equals to twice of crank radius. So from here crank radius you will be getting half of 350, that is 175 mm. So that is 0.175. Rotating mass 30 kg. Crank radius 0.75. So balancing mass you will be getting from here very easily. Balancing mass. Yes, engine reciprocating. Yes, reciprocating masses cannot be balanced completely. That's why we are preferring partial balancing. What is this answer? Balancing mass value MB. Please do the calculation. Do the calculation and tell me your answer. $27.3. Yes. Now next is the unbalanced force at a crank position of 45 degree from the dead center. Now see this one. So there are two forces. Unbalanced force along the line of stroke, and second one is perpendicular to the line of stroke. So along the line of stroke, the formula is 1 minus C mr omega square cos theta and here it is C mr omega square sin theta. Individually both the values you will calculate and then you will write resultant unbalanced force. Resultant unbalanced force will be first of all along the line of stroke plus perpendicular to line of stroke square. So from here you will get resultant unbalanced force as well. Do this calculation part, then I will give you a detailed description about all those values, how we got these formulas. First do the calculation this much, everyone. Mass, obviously reciprocating mass we have to put here. Okay, individually calculate both the values and finally this resultant unbalanced force also. Do the calculations. Into omega square. Omega they have mentioned. Okay, 150 RPM they have mentioned. Okay. So omega we have to calculate like this, 2 pi into n. Two pi n by 60. So 2 into pi into n, 150 divided by 60 it is there. So 15.7. 7079. Right. 15.7079 square into cos theta. Cos theta means cos 45. Right, cos 45. Then we have 0.5 into m, 40 into r, 0.175. 15.7079 square into sin 45. Right, like this. This way. Okay. Calculate both the values and tell me the answer. $41.23 is the final answer you're getting. Just cross check. No, 41.23 is not the correct answer. Aditya, just cross check the calculations. Maybe somewhere you have done the mistake, because 41, that small value will not be there. At least 3-digit number will be there, not 2-digit. See, 0.5 into 40 into 0.175 into 15.7079 square into cos 45. So it is coming 610.645 Newton. Now, next, if I talk about this one, 0.5 into 40, actually answer will come same, because C value is 0.5 now, so it will come same. Sin 45, cos 45, again it is same values. So answer will come same only, both the values, 15.7079 square into sin 45. So same value, 610.645 Newton. Maybe somewhere you have done the calculation mistake, that's why you are getting wrong answer. Okay, so just please cross check it. So 610.645 square. Okay, so it will come around 863. Final answer will be approximately 863.58. 863.58 will be the answer. So you didn't square, that's why you're getting wrong answer. Okay, no issue. Now let me give you a brief detail about how all those formulas will be getting and how to use these formulas. I took omega instead of omega square. Oh, that's why you are getting less value. So omega square is there na formula. In the formula it is omega square. Got it? Now let me tell you the detailed description about this word. Partial balancing of reciprocating masses. Partial balancing of reciprocating mass. Let me show you here the diagram here first of all. So this is what the single threaded crank mechanism we are having. Okay, now see. So this is what the crank. Okay. Now what we will do, we will attach a balancing mass here opposite to this crank. Okay. Now please see everyone. Now this is what the balancing mass MB and this is RB. What is this angle? This is the rotation of the crank, theta. This is also theta. Now it's one of the component is like this, MB RB omega square cos theta. Why MBRB omega square? That is centrifugal force, na? It is going to rotate. It is also connected at this is what crankshaft. See, this is your crankshaft. On this crankshaft, there is a mass attached to it. When crankshaft rotates, that mass is also going to rotate like this. For that rotating mass, what is the unbalanced force? Centrifugal force. MBRB omega square cos theta, and here it will be MBRB omega square sin theta. MBRB omega square sin theta, it is there. Fine. Now, one more important detail. What is the unbalanced force for the reciprocating masses? Unbalanced force for the reciprocating masses is MBRB omega square, MR omega square cos theta. And I am considering the primary unbalanced force only, not the secondary. Because the magnitude wise, primary unbalanced force is more. Magnitude wise, primary unbalanced force is more compared to the secondary one. So we'll talk about the primary unbalanced force only. Now, important thing is, what is the net force along the line of stroke? What is the net force perpendicular to the line of stroke? Now we can easily mention. Net force along the line of stroke will be the difference of this and this value. Perpendicular to the line of stroke, only this force it is there, right? So its maximum value is actually equals to the hammer blow. Maximum value of the net force perpendicular to the line of stroke is actually called as hammer blow. I hope you got the point. Now we'll write down the values here itself. Okay, let me write it on the next page. Along line of stroke. So what you will write? MR omega square cos theta minus MBRB omega square cos theta. Now, very important relation you need to understand for partial balancing. MBRB equals to C into MR. C is the percentage of partial balancing you are doing. So that's why C value will range from 0 to 1. Between 0 to 1 it will be there. So C is the percentage of partial balancing. 50%, so 0.5 value. 70%, 0.7 value. 80%, 0.8. Like that, the C value, you have to write it there. Clear, everyone? So MBRB, instead of writing MBRB, CMR we will be writing. So the formula will be, accordingly it will change. CMR omega square cos theta. So 1 minus MR omega square cos theta I will take common, so remaining thing will be 1 minus C. This is what the net unbalanced force along the line of stroke. Then second one is perpendicular to line of stroke. Perpendicular to the line of stroke. Fine. Now that there is only one force, MBRB omega square sin theta. Okay, so instead of writing MBRB, we will write CMR omega square. Okay, please keep in mind here that MB is balancing mass. RB location. And what is M? M is the mass of reciprocating. Reciprocating mass, it is there. reciprocating mass. Clear? So m is the reciprocating mass. R is what? A crank radius. In most of the question, they will give RB as the crank radius only, but in some questions, it might be different also. So we should be aware of the information given in the question, right? Aditya, I hope this much data is clear to you. Tell me, this much part is clear? Yes or no? Is this point clear, Aditya? Tell me. Clear now? Okay, super. Now, see, in the last, I want to just highlight the important things that you need to cover. Okay, one by one, I am writing angular velocity ratio theorem. Okay. Second, angular velocity ratio theorem for the Aditya, that is what the whole derivation part only. Okay. That is what the whole derivation part for this one. Unbalanced force along the line of stroke, unbalanced force perpendicular to the line of stroke. And we are writing partial balancing of reciprocating masses. In that we are considering primary unbalanced force only. There is a secondary unbalanced force also, but we are limited to primary unbalanced force just because magnitude wise this one is more. So we have to focus on this one first of all. Secondary unbalanced forces we have not considered. So that's what, based on primary unbalanced force only, I have done all those derivation part. Right. So angular velocity ratio theorem from the simple mechanism topic. That is very important. Then we have epicyclic gate train. Questions from epicyclic gate train. And specifically what you need to use, relative velocity approach. Relative velocity approach. Okay. Then we have vibration. In vibration, whatever today we have mentioned, everything you have to cover. Because in vibration we can't tell na ki, okay, this one is important, this is not that much important. Everything in the vibration is important. Everything means everything. Forced vibration, damped vibration, natural frequency, all those things are important here. Then after that, flywheel. In flywheel already I have told you there is one formula only. Delta E equals to I, mass moment of inertia into omega square. Omega means average omega or mean omega into CS. All the questions are from this formula itself. You need to know how to calculate delta E. So that delta E calculation you need to know. Work done per cycle, how calculations you will do. All those things you should remember. Okay, after that, finally, if you have to see angular velocity ratio theorem from simple mechanism. Apart from that, you can write here from first chapter, single slider crank mechanism also. Single slider crank mechanism also you have to see. Okay, like crank slotted quick return motion mechanism, Whitworth quick return motion mechanism, kinematic analysis of single slider, dynamic analysis, all those things. So from gate train, epicyclic gate train is the most important. Vibration, entire everything important in vibration. Then flywheel, this formula only, very easy. Then after that, balancing. In balancing, what is required? Force balance, moment balance, that's it. Summation of forces has to be what? 0. And summation of moment has to be what? 0. This is what we need to take care. Then later on after this, governor, very like chances are questions from governor is like very less. Last year I think till now they've asked 2-3 questions, and that too like very simple questions. Governor, if you have not prepared, no need to touch. Okay, then you have gyroscope, again gyroscope, if you have not prepared, no need to touch as of now. Then cam and floor, very less number of questions. So this is what I'm telling. If you have not prepared and if you have limited time, where you need to focus more: angular velocity ratio theorem, single thread recurring mechanism, epicyclic gate train, vibration, flywheel, balancing. These 4-5 topics you need to cover. This much. No need to cover entire syllabus. If time is what limited, how you will be able to do all those things? Not possible, na? So we have to be what very focused on those things which have the high weightage, or chances of question coming from those topics is very high. So we have to be focused about all those things. Are you getting the point? So that's what I'm telling. This 5 topics I've mentioned here, so that you will have an idea. Okay, I need to put my energy, put my efforts on these things only. So that's very good, Aditya. Leave the governor topic, no issue. Gyroscope you have to do. Yes, correct. Mass amount of inertia into omega of spin multiplied omega of precision. Absolutely. So whatever that in gyroscopic couple, what is required? How to identify the direction of gyroscopic couple using right hand thumb rule. That's it. Okay, nothing more than that. But as a subject point of view, I'm telling these things are more important compared to other things. Even if you are focused on this one, you will be able to score good marks in theory of machine. Right? I hope that vibration questions you have enjoyed. Balancing part also you have discussed. Okay, in the yesterday's lecture, simple mechanism, so many questions we have solved from the simple mechanism. Then we have questions we have solved from flywheel. Questions we have solved from gate train as well. So whatever we have discussed, those are like very important numericals and topics we have covered. Not complete the whole syllabus part, but important things we have covered here. Right? So I hope you have enjoyed the session, Aditya. Later on in the next January month, we will be coming with the revision session. Revision session means what? Each and everything in the whole subject we are going to revise. Till then, stay tuned with the IMS Gate Academy YouTube channel. Okay. Yes, questions were new. That's what very important. Guest booster series purpose is what to discuss a new variety of questions. Right? You will get the PDF if you join the Telegram group. If you have already joined, you will get the PDF of the whole lecture that we took in the yesterday's session also and today's session also. Complete PDF you will be getting there in the Telegram group. Right? So thank you so much everyone, and keep enjoying the session, and please, you have to make it possible this year. You have to try whatever it requires, do whatever it possible, do everything which is there. You should not be leaving anything. Give your 100% effort for your GATE preparation, so that after the GATE examination you will feel proud. Yes, I've done the preparation and I will be getting the result. So time is very less. You have to be very focused. You have to sacrifice so many things. But yes, if you are focused and you are ready to sacrifice the things, definitely result will be with you only. Right? Thank you so much everyone.